Hi guys, my name is Ram Prasad. I am saying about the operating system lab, and let's see the experiment number 4, CPU scheduling algorithm. Let's see the aim to write program to implement CPU scheduling algorithm for first out come first serve SJF priority and round robin scheduling using C++ or Python. Process scheduling. Processes are the small programs that those are executed by the user according to the request. CPU executes all the process according to some rules or some schedule. Scheduling is that in which each process has some amount of time of CPU. Scheduling provides time of CPU or to the each process. Types of process scheduling. Types of process scheduling. FC, FCFS scheduling algorithm. The first come first served FCFS scheduling algorithm is the simplest one. In this algorithm, the set of ready processes is managed as FIFO first in first out queue. The processes are serviced by the CPU until completion in order of their entering in the FIFO queue. A process once allocated the CPU keeps it until releasing the CPU either by terminating or requesting, that is, for example, interrupted process is allowed to continue running after interrupt handling is done with. Let's see the program. This DCF definition DEF FCFS burst time print process burst time waiting time turnaround time, that is waiting time is equals to 0, turnaround time is equals to 0, MT1 MT2, while I less than burst time turnaround time plus is equals to burst time, and print P plus still Y plus 1 plus T plus still burst time plus TTT plus still waiting time plus TTT plus still turnaround time. MT1 append waiting time, MT2 append turnaround time. Waiting time plus is equals to burst time, and 1 is equals to I plus is equals to 1. Return MT1, MT2, MT is equals to enter enter number of process. Burst time for I is equal I in range NP. Burst time append in input enter the burst time for process plus still I plus 1 plus list is equals to FCFS burst time. Print average waiting time plus string sum list less than divided by len list. Print average turnaround time plus string sum list divided by len list 1. And let's run the program. Enter the process 5, 42, 5, 3, 7, 10. And we can see here process burst time, waiting time, turnaround time. P1, P2, P3, P4, P5. P1 42 burst time, waiting time 0, turnaround time 42. P2 burst time 5, waiting time 42, turnaround time 47. P3 burst time 3, waiting time 47, turnaround time 50. Process 4 burst time 7, waiting time 50, turnaround time 57. P5 burst time 10, waiting time 57, turnaround time 67. Average waiting time 39.2, average turnaround time 52.6. And let's go to the second one, SJF scheduling algorithm. The shortest job first scheduling algorithm chooses process that has the smallest next CPU burst. Let's go to the program. Def def SJF burst time, comma x print process burst time, waiting time, turnaround time. I is equals to 0, waiting time is equals to 0, turnaround time is equals to 0, MT1 is equals to MT2 is equals to, while I less than len burst time turnaround time plus is equals to burst time print p plus till x dot index burst time I plus 1 plus t time plus string burst time I plus time and x string waiting time plus string turnaround time x dot index burst time I is equals to minus 1 mt1 append waiting time mt2 append turnaround time waiting time is plus is equals to burst time I plus is equals to 1 return mt1 mt2 np is equals to int input enter number of process burst time is equals to for I in range burst time append int input to enter the burst time for process plus till I plus 1 plus list is equals to SJF sorted burst time comma burst times print average waiting time plus string sum list divided by len list print average turnaround time plus string sum list 1 divided by len list 1. Let's run the program and enter number of process 4. First one 32, second one 7, third one 9, fourth one 5, and, and process burst time waiting time turnaround time p4 p2 p3 p1. First one 5 p4. Let's see the first one p1 32 waiting time 21 turnaround time 53 p3 first burst time 9 the waiting time 12 turnaround time 21 p p4 first burst time 5 waiting time 0 turnaround time 5 and average waiting time 9.5 average turnaround time 22.75. And let's see the third one priority scheduling. And priority scheduling is one of the most common scheduling algorithms in batch system. Each process is assigned a proper priority process with the highest priority is to be executed first and so on. Let's see the program. Define priority burst time priorities print process burst time and waiting time turnaround time I is equals to 0 waiting time is equals to 0 turnaround time is equals to 0 mt1 mt2 while I less than then burst time k minimum priorities turnaround time plus is equals to burst time priorities index print p plus string priorities dot index k plus 1 plus time t plus string burst time priority dot index plus t plus string waiting time plus t time plus string turnaround time mt1 append waiting time mt2 append turnaround time waiting time plus is equals to burst time priorities dot index I plus 1 is equal I plus is equals to 1 priority dot index is equals to maximum priorities is equals to is equal plus 1 return mt1 mt2 and p is equals to input enter number of process burst time is equals to priorities for I in range burst time append into input enter the burst time for process string I plus 1 is equal I plus 1 plus 1 for I in range priorities append into input enter priorities p plus string I plus 1 plus and less priority burst times priorities print average waiting time plus string sum lis len divided by len lis average print average turnaround time plus string sum lis 1 divided by len lis 1. Let's run the program. Enter the process 4 p1 3 6 8 10 p1 4 6. And let's see the fourth one round robin scheduling. The scheduling algorithm is designed especially for time sharing systems. It is similar to FCFS scheduling, but prevention is added to switch between process. And let's see the program. Define round robin burst time, comma TQ copy 1 burst time, copy 2 burst time, copy 3 burst time, process I plus 1 for I in range length, copy 2, W is equals to 0 while copy 2 dot count none, exclamatory mark is equals to length for len copy 2. If copy 2 w is equals to none, k is equals to copy 2 w minus tq. If k less than 1, copy 2 is equals to none, else copy 2 w equals to k. If w is equals to then copy 2 minus 1 w is equals to 0 for k in range. Then copy 2, if copy 2 is less is equals to none, process dot append k plus 1, else w plus is equals to 1, else if w is equals to then copy 2 minus 1 where w is equals to 0 for k in range. For k in range, len copy 2. If copy 2 is k is equals to none, process append k plus 1, else w plus is equals to 1, s is equals to 0, waiting time is equals to I is equals to 0, like j is equals to 1, while true if I is equals to len copy 3, I is equals to 0, j is equals to 1, if burst time is equals to none, k is equals to burst time minus tq. If k less than k greater than is equals to 1, s plus is equals to tq, waiting time append dot append burst times is equals to k, j plus is equals to 1, else if k less than 1, s plus is equals to burst times waiting time append j plus is equals to 1, burst times is equals to none, y plus is equals to 1, else if burst times count none is equals to len copy 3 break, else I plus is equals to 1 dot is equals to list zip process comma waiting time q is equals to 1, sequence is equals to 3 is equals to 1, while q less than len copy 3 plus 1 list is equals to for I in range t comma len dot. If dot I is equal 0 is equals to q, less append I, q plus is equals to 1, t plus is equals to 1. If less is equals to 0, list dot append 0, sequence dot append list p is equals to 1, s is equals to for I in range then sequence total is equals to 0, j is equals to 0. If maximum sequence I is equals to 0, a waiting time I, a insert 0 comma 0 for k in range length a minus 1 comma 0 minus 1, total plus is equals to ak minus 1, san dot append total dot pop, and while j less than maximum sequence I, if dot j plus 1 0 is equals to I plus 1 dot plus dot j plus 1 1 minus dot j 1, j plus 1 is equals to 1, j plus is equals to 1, if else if dot j plus 1 0 is equals to I plus 1, j plus is equals to 1 if j is equals to maximum sequence I minus y, if I less than I greater than 0, total plus is equals to waiting time I minus 1, san dot append total top dot pop 0 break, print process burst time waiting time turnaround time for I in range length burst time, print p plus still I plus 1 tt plus still copy plus ttt string san I plus ttt string san I plus copy 1 I, return sum san len san comma sum list map sum comma zip copy 1 comma san len divided by san len san, np is equals to int input enter number of process, burst times is equals to priorities is equals to for I in range burst time dot append int input enter the number burst time for process plus string I plus 1 plus time quantum is equals to int input enter the quantum ln is equals to round robin burst times time quantum into average waiting time plus less is equals to 0, print average turnaround time plus string list 1, and let's run the program. Enter the process 5 burst 33 42 8 6 5 quantum 6, and process burst time waiting time turnaround time p1 33 49 82, p2 42 52 94, p3 8 35 43, p4 6 18 24, p5 5 24 29, average waiting time 35.6, average turnaround time 54.4. Thank you guys by watching my video.